A team I helped had a support automation that looked impressive in a demo. It read a bug report, opened the codebase, proposed a patch, ran tests, and updated the ticket. Then production found the missing piece. One ticket had flaky tests. The agent kept changing the same 2 files, rerunning the same failing suite, and writing confident ticket updates every few minutes. 19 hours later, the bill was real, the patch was worse, and no human had been paged. The model was not the root cause. The loop was. The phrase AI agent gets used for almost anything now. A chatbot, a script, a workflow, a model with a tool attached. That fuzziness is expensive. If you treat an agent as magic autonomy, you skip the engineering that makes it safe to run. A one-shot prompt gives the model one chance to answer. An agent loop gives the system more chances to act, observe, and choose again. That power cuts both ways. Without limits, it can repeat itself. Without state, it can forget what it already tried. Without verification, it can declare victory because the text sounds right. The naive version breaks because nobody owns the next decision. Here is the clean definition I use in production. An AI agent is a large language model plus tools, running inside a loop with stop logic. The model supplies judgment and language. The tools touch the outside world: search, files, databases, browsers, code runners, ticket systems. The loop decides when to ask the model, when to call a tool, when to feed observations back, and when to stop. That loop is code you own. It is not inside the model. Opinionated take. The intelligence is rented. The reliability is engineered. You can swap models and keep the same harness. You cannot swap in discipline after an uncontrolled loop is already running. Mechanically, most agents follow the same skeleton. Start with a goal, a state object, an allowed tool list, and budgets. Call the model with the current state. It returns a decision. Answer now, call a tool, ask for clarification, or fail. If it calls a tool, your code validates the request, runs the tool, captures the result, and appends an observation to state. Then your verifier checks progress against the goal. Only then do you loop. Every pass should ask, are we done? Are we stuck? Are we unsafe? Or have we spent the budget? The model may suggest the next move, but your harness grants permission and owns the exit. Picture a small research agent that summarizes a new internal security policy. A one-shot prompt might say, read this and summarize it. An agent version has a little autonomy. Step 1, inspect the policy title and missing context. Step 2, search the approved document store. Step 3, open the top results. Step 4, extract claims with citations. Step 5, verify that each recommendation points to a real source. The loop stops when it has 5 relevant sources. Every key claim has evidence, or the search budget is exhausted. Notice what we did not do. We did not say, be an expert researcher forever. We gave it a job, tools, boundaries, a memory of what happened, and a finish line. Even with a proper loop, agents fail in boring ways. They repeat an action because the observation was too vague. They trust a tool result that was partial, stale, or empty. They keep a pending state until the important facts are buried. They hit a goal that humans would call incomplete because the done condition was underspecified. Autonomy is a dial, not a switch. More autonomy means more decisions delegated to the loop. That can save labor, but it also increases the surface area for mistakes. A reliable agent is usually less romantic than the demo version. Fewer tools, tighter schemas, explicit budgets, dull logs, and a clear path to human review. This definition is the foundation for everything else in loop engineering. Stop conditions decide when the loop ends. Verification decides whether progress is real. State design decides what the model can remember and what your code can inspect. Budgets prevent a cheap task from becoming an expensive incident. Guardrails constrain which tools can run, with what inputs, under which permissions. Orchestration handles multiple loops without turning them into a pile of hidden side effects. When someone asks, what is an AI agent? The useful answer is not a personality. It is a control system around a model. Try this. On one of your own automations, pick a task where you currently send one big prompt, like drafting a report, triaging a ticket, or checking a document. Write down the goal, then write the next possible decisions. Answer, call a tool, ask a human, or stop. Add one budget, such as maximum 3 tool calls or maximum 5 minutes. Add one verifier, such as all claims need links, tests must pass, or output must match a schema. You do not need a framework. A plain function with a loop is enough. The exercise is to move from asking the model to solve everything to owning the control points around it. 3 beats to keep. First, an AI agent is not just a smarter prompt. It is a model, tools, a loop, and stop logic. Second, the loop is code you own. That is where budgets, verification, state, permissions, and escalation live. Third, autonomy is adjustable. You choose how much the system can decide before a human or another control takes over. If you remember one line, make it this: the intelligence is rented, the reliability is engineered. This is Loop Engineering, a daily series on building agent loops that finish, verify, and stop. New episode daily on this channel.